All right, so on 6.3 is trig equations, and it's just a different version of trig equations using half angles and double angles. So first up, we have solving the equation with a half angle. So you have 2 sine x over 2 equals 1 over the interval 0 to 2 pi. Okay, meaning that your x value can't be bigger than 0. This can be bigger than 0 but less than 2 pi. Okay, so when we talk about in terms of this, we're going to only be looking at sine being positive. And sine is positive in quadrants 1 and in 2. Reason being we're looking at sine being positive is because if I was to get sine x over 2 by itself, it becomes sine x over 2 equals 1/2. Does that make sense? So that's why we're only looking in quadrants 1 and 2 right now. Okay, so in quadrant 1 and in quadrant 2, when does sine equal 1/2? And where else? Perfect. Okay, so we get sine equals 1/2 at pi over 6 and 5 pi over 6. Now, the thing is, we need x over 2 to equal pi over 6 or x over 2 to equal 5 pi over 6. So we're going to set up proportions. So you set up your two proportions. So you have x over 2 equals pi over 6 or x over 2 equals 5 pi over 6. And how do we solve proportions?
Is it the cross multiply?
Cross multiply and divide. So in order to solve, we're going to cross multiply. X times 6 gives us 6x. 2 times pi gives us 2 pi. 2 pi divided by 6 equals pi over 3. And you would do the same thing for this one. X times 6 is 6x. 2 times 5 pi is 10 pi divided by 6 gives us 5 pi over 3. So your solutions are
3, 4, 5, 5 over 3.
And that is your solution set. Okay. Now, the next part it says for all solutions. So it's just saying, as this pattern keeps going, when does this happen? Like, when will I have these values? So there's a couple ways of looking at it. It's going back to our function rules. So on analyzing this as a function, in order to analyze this as a function, you would subtract 1, right? And then look at what's your A, your B, your C, your D, correct? And remember, each variable plays a role. Your A is your amplitude, your B is your horizontal dilation, and your D is your vertical translation, right? Makes you go up and down. So let's look at it graphically. So in the calculator, if I was to graph y equals 2 sine x over 2 minus 1, I would be looking for when am I having that point? When am I hitting here and there? Like, where is it happening? And so it happens every 4 pi. But I also know it's happening every 4 pi because my period is 2 pi divided by b, right? Y'all remember that? So we know that p equals 2 pi divided by your b. And our b is 1/2. So my b is 1/2. That means my period equals 4 pi. So that's why every 4 pi, I'm going to have a solution set. I don't know why they wrote 4 in pi instead of just writing 4 pi in like most people do. But every time I go 4 pi, I'm going to have a solution set that satisfies that equation. Meaning that that's what it's going to be on the x-intercept, right? So every 4 pi, I'm either going to be at a multiple of pi over 3 or a multiple of 5 pi over 3. Okay? And so this is what your full solution set would be.
So to find that number, it would be 4 pi times that in.
Yeah, to find the next number. So if I said, what are 2 more iterations of your solution set? then you let n equal 2, n equal 3, and figure out the rest. Well, but n equal 1, so I skipped over 1. Let n equal 1, n equal 2. And you'll have another set of data. Okay. All right. So there's that. Example 2 is about using your identities again. So going back to our cosine double angle identity, because it says cosine 2x, so chapter 5, 5.4. For cosine double angle, there's like 3 different identity substitutions, right? Well, we want to use the one that makes the most sense for our problem. And the one that makes the most sense is the one that only uses cosine and allows us to turn this into a quadratic situation. So the identity that we're going to use is cosine double angle equals 2 cosine squared x minus 1, which is what we use most often in chapter 5 anyway. So now that we plug that in, you either can use substitution or understand that this is just a quadratic problem now, right? And because it's a quadratic problem, I need to get one side equal to 0. So I'm going to get this side equal to 0 by subtracting cosine. So now all I have is 2 cosine x squared minus cosine x plus 1. And I'm asking myself what multiplies to give me 2, but adds to give me negative 1, right? And I do the math, and it's going to come down to this factored form. If you need to see it as U's, so in terms of U's, you have 2, that's a 2, we're going to believe it's a 2. U squared minus U plus 1. And you solve that by grouping, solve it by box method, however you want to solve and set it up. Just remember that U represents your cosine. And so once you're done factoring, you can plug cosine in for you. Okay, now, just like in Algebra 2, which we're currently doing right now, you take each factor and set it equal to 0. So we're going to take each factor and set it equal to 0. Now that each factor is set equal to 0, then you're going to solve for cosine. So in order to get cosine by itself here, what are my 2 steps?
Then divide by 2.
Subtract the 1, then divide by the 2, which gives us negative 1/2. So on your unit circle, what does cosine x equal negative 1/2? Has to be in quadrants 2 and 3.
Yeah. Let me just look at it.
Try to visualize it.
Yeah. I know it's just not coming to words. At 120 and then 240, or 2 pi over 3 and then 4 pi over 3.
Perfect. So you end up with first set of answers. Okay, over here, we need to get cosine by itself. So in order to get cosine by itself, what will we do? Add 1. So now we're asking ourselves, I don't know why they didn't add the 1. This should be add 1. So now we're asking ourselves, when does cosine equal 1?
And whoa, with 0.
At 0. Cosine equals 1 at 0. So your solution set is 0, 2 pi over 3, and 4 pi over 3.
And do you not add 2 pi into that?
Nope, because notice right here, it's not a
Oh,
bracketed
because,
thing,
yeah.
parentheses.
Yeah.
All right. Cool. Okay. Example 3. So example 3 again, we're using our identities, but this time we're going to use our sine double angle. We're going to have to do a little bit of manipulation to be able to apply it. So the first thing is for sine double angle, it has to be written in the format of 2 sine theta, cosine theta. So all we're going to do is factor out a 2 so that we can have our rule so we can use substitution. So we're going to substitute that in with sine 2 theta. So now we're going to substitute it in with the double angle. And we need to get our double angle by itself. So what do I need to do? Divide by 2. Now, this is where they mess up in their notes. I do not know why the entire square root is over. It is just over the square root of 3. It is not over the 2. Okay. So on your unit circle, when does sine equal a positive square root of 3/2?
Pi over 6. No, don't listen to me. And pi over 3.
There we go. And
And 5 pi over 3.
and 5 pi over 3. So those are our anchor points, right? So we know that on the interval from 0 to 360, we're at 60 and what is the other number? 300. So you're going to be taking each one of these, so 2 theta, and setting it equal to the 60. So you have, it's a weird thing, 2 theta equals 60 plus, I don't know why they don't put it here, 360 in, because you can go around the circle more than one time. Okay, your theta has to be between 0 and 360, not your overall answer. Does that make sense? So you would solve this, so you have to let n equal 0 to get a value. Then you'll let n equal 1 and get a value. Then you'll let n equal 2 and get a value. And you'll let n equal 3 if it's still satisfied between 0 and 360. So when I let n be 0, that just makes this 60. So 60 divided by 2 is 30, which is how we end up with 30. Does that make sense? Now we're going to let n equal 1. So 360 plus 60 gives us 420, right? 420 divided by 2 gives us 210. And then we're going to let 2. So that's 720. 720 plus 60 is that 80?
780.
780. 780 divided by 2 gives us 240. Okay, so that's how that came into play. Now, how did we get the other values? That's by the fact that what was our other value that gave us square root of 3/2?
The 300.
The 300, right? So with your 300, was it 300?
Yes.
Yeah. You would do the same
Wait,
thing?
no, sorry. I'm looking at the wrong thing.
Okay.
330.
330, right? Okay, I was like, wait, 300? Hold on. So at 330, we would do the same thing, right? Except 330 is only going to happen at 1. So it's not going to allow us to keep going. So that's how you check those values.
Okay.
And then, yeah. And then this is for all solutions. It's just asking what is the rule or pattern that you're following. So your all solution would be where you show that n is included. Okay, so 2 theta equals 60 pi plus 360 n. And they messed up because the side was it side? Oh, it is in quadrant 2. It should be 120. The side is negative in quadrant 4. Yeah, I was like, we're messed up somewhere. There it is. Found our mistake, blame it on the bit drill, and then you can go ahead. And that's all that section is about.
Yeah, that makes more sense. I just couldn't understand the guy, and I was trying